Alrighty, so a couple things. Zybooks, right? We're up to files here. There's no Zylabs for inheritance and recursion, just a little bit for this Python for data science module here, just a couple practice ones. Doing something with NumPy is really cool, Pandas is really cool. So we're just like introing you. These are really cool libraries people use when we do data science work, because nobody wants to reinvent the wheel. You can do whole studies on these. There's lots of good YouTube series out there if you want to do more with these. And then doing plots, which is super fun. The PY plot, I think I showed you a couple of those a while back. Here, once we get to having data we can plot and make pretty pictures with, you can do a lot of really cool stuff. So that gets to be a lot of fun. So we'll get into all of those as we go. We're just kind of introing the topics as a, hey, here's more fun stuff to come. But we are almost done, right? So we've got this week of files. There's a lot to files. So we got to talk about the project 3 solution. We got to talk about the final project, and we got to start talking about files. Today, we'll finish up files on Wednesday, and then we're off for a whole week. So I should be able to do the due date for next 2 weeks for the lab, right? So nothing will be due next week. Just remind me, because sometimes I forget to bump it out an extra week when I set up the lab. We'll pick up those extra topics the week after Thanksgiving. The week after that is just final project work time. So again, if you want to work with a partner, I'd recommend it, but I'm not going to require it because it's not a goal of this class. Next class, you will have to work with a partner if we do continue on, as learning to work in groups is important. And it's much more fun to work with people. Like, it's really lonely to sit in a corner and just do stuff and never talk to anybody. So, and then final project presentations a month from today. Okay, so we've got a month to work on this final project. Right? That's sort of the goal with it here. Okay, all right, awesome. All right, we're getting there on the Zylabs here. Again, they don't get faster, I promise you. They really don't. So what I'll probably do at the end of maybe the start of this week or something, final project work time, I'll put in a temporary score for Zybooks just so you can see what the score is. And then I'll run it again the day of final projects for you to put a final Zybooks score in. But that way you'll know how much out of the 10 points or 10% you got, right? Because that maybe it'll make that a little bit more clear for you individually here. But I can do that for you and throw that in. So the lab on 12/9 as well will also just be final project work time. So we've got the lecture times and the lab time that week as well. So if you want to get together with your partner and work, if you want to show me what you're working on, I can look over your shoulder really easy. I can always do Zoom calls or things, and screen shares are pretty quick too if you need to troubleshoot something. We can go from there. So, all right, let me fire up PyCharm. And we'll do a new, this is chapter 12. All right. Now, files are lots of fun because we finally get to something where we can have data that stays after the program is done running. Right? Everything we've done up to this point here, we only have data when the program is running, and someone's probably typed it in, or we've hard-coded something in here. So once we have a file, we can get information and save it to a file, and we can go do something with that file later. Right? It's going to allow us to hold on to information, and that'll be a key part of the final project here. Essentially, we're going to save and load. Right? We can save the state, and then we can load the state to resume where we were before when we're going here. So this was, I already forgot the chapter number. Chapter 12 files. Alrighty. So one of the weird things that we have to think through, right? The hard part of working with files, if we want to be using them for our custom purposes, if we know how we want to read the data out of a file, we know then how we need to write the data. Or if you want to figure out, okay, I've got a bunch of data, this is how I want to write it, then okay, if I write it this way, I have to read it that way. Right? They go hand in hand. So if I want to save my information somehow, however I save it is however I need to read it. Or if I want to plan, hey, I want to read this information out of the file, well, I have to write it in that particular order here. So to add just a file here, I'm just going to go new, and everything we're going to do here is with text files here. So I just do a new file. This is, I will do games. Oops, I should have, hang on, games, let me rename that. Rename games.txt. So a .txt file is a text file. It's just a plain text file here. So if we open this up here, we open an Explorer, we open up files, we'll see here's a games.txt. Windows knows, or your Mac OS knows, if it's a TXT file, you open it up with a text editor, like Notepad or something very basic here. So you can open it, you can view it here. So if we list out some games here, maybe we have Settlers of Catan, maybe we have Monopoly, maybe we have Risk. What are some other five? I'm really bad at this sort of thing here. Memory is not my strong suit, believe it or not. Oh, we can put some games in here. Sorry, it's a classic one. Chutes and Ladders, right? Think way back to when you were little. Chutes and Ladders, or Candyland. Oh man, I've got little kids at home right now, so Candyland is a hot one here. But I'm just going to save that here. And now when I come back to PyCharm, it has that file open, right? So you work in the file, you can edit it in PyCharm, you can edit it in your Windows editor, or whatever you want here. That's the wrong file. This one here, right? And keep it open, it's fine. All right, so we've got a list of games here. This is not a very interesting file, but it's got a bunch of things, and everything's on its own line. So the way that this data is stored, I know I need to read it, and every line will have a game on it. Right, so I can go maybe make a list of games, and I can pick a random one out and be like, hey, it's Friday night game night, here's a random game to play. And everyone cheers, or something like that. Or they complain because no one likes Risk, which is really sad because Risk is a lot of fun, but you don't make friends playing Risk because two people can't win the game together, right? And I guess you could agree to just draw the game, but then you're both losers because no one actually won, right? You don't have two winners, you only have two losers. All right, so to open a file here, and I'm just going to go copy paste out of here because that's so much easier than trying to remember how it looks here. We're going to go read a file. In Python, you say you want to open, and you give it the name of a file. Actually really easy, which is nice. So we'll just say, again, I don't like F. F is silly here. So this is my games file. And I like very descriptive variable names here. Equals open, and you give it the name of a file here. So it's not my file.txt, mine is games.txt. Now, they don't have to be .txt files, but when we open the files for reading, we're only going to read them out as text. So .txt is just information for your operating system to know, hey, it's probably a text file. .py files are Python files. They're also text files. Right? We can open Python files in our Notepad editor if we so care to. Right? It's just ugly, and no one wants to code in Notepad because that's terrible. So I can say, hey, open this with Notepad, and we see the code in here. This is my Python file. Right? It's just text. Right? Python files are text, but the Python interpreter goes and reads that text and says, okay, I'll do the things you asked me to do, and I'll ask the operating system, right? It sits in between your code and the operating system to manage all that other stuff for us, which is really fun. All right. So we got our text file. We open it up here. Then a couple things you can do. You can read the entire file into a single string. Depending on what we're doing, this can be helpful. I'm not a big fan of read because you get one string with everything in it. So if I wanted to turn that into a list of games here, it's not going to work very well. So read lines is much more common. Read lines says, give me each individual line as its own string here as a list of strings. So I'll get a list of strings back here, and each string in that list will be each individual line, and it's going to have pulled out all those /n's, all the new lines here. Because doing all the /n's is a little bit obnoxious, having to manage those ourselves. So I can say, here's my games, then will be my games file.readLines. It's going to go and try and read all those lines. And then I can say for game in games, we'll just print the game. Again, not very interesting here. We'll just print each line, right? For each item in this list here, go and print it. And now we get out our games. Notice they're double spaced. I'm sorry, it doesn't take care of the new lines. I forgot. I can never remember which one does it. So each line still has the new line character at the end. So when you look at what's saved in the text here, there's actually a new line character, and it's keeping that as it was here. So maybe then I don't want to print each one here. Maybe I want to change the ending character to just be nothing, because I know they already have new lines there, right? So if we were to run this in debug mode and look at what's stored, we can go through and let me step over. And now I see here's my games list. So see each of these has that /n. PyCharm is showing us the new line character is there that it read out. And notice Candyland doesn't have the new line character, which is kind of sad, but that's okay. Poor Candyland. Right? We didn't go down another line here at Candyland. It ended at line 6. That's all. Okay, so we can read them all out as we go. So reading a file is not too bad, right? Just say open it, give me all the lines, but you have to know what you're expecting at every line. Right? We have to know, okay, here's what's going to be at this line, here's what's going to be at this line, here's what's going to be at this line. What if we wanted more information about our games? What if we wanted to know like how many players this game is for, right? Usually when we're going to play a game, you need to know, oh, I've got 6 people who want to play. I need a game that at least 6 people can play, right? So we need to have some sort of list of players, right? How many players can go? And depending on how we want to write that or read that, we can do that. So maybe in my games file here, we'll go change this. So Settlers of Catan we'll say is, 2 to 4 players. Monopoly is 2 to 8 players or something like that. Risk, I think, is 2 to 6. Sorry is 2 to 4. Shoots and Ladders is 2 to 6, probably. 4, I don't even remember here. And Candyland is probably 6 as well. I forget. So we can put in more information here, right? So number dash number. But now when I go read it out here, not every line will be a game, right? I'll still get the information back out here, but to be able to use this here, it's just a line right now, so it's not going to be useful to me unless I can go and convert it here and go read that information as I go. So maybe I need to read the name of the game and then read the next line is how many players are in it here. So I might, if I know they're always going to come in pairs here, right, I can read them in pairs as I go. So instead of just looping through the entire list here, we can say for index in range length of games, and then when I range, I want to step by 2. Right? I want every other one. I think I need to give it 0. Sorry, I think I need, if I want the step, I need to say start at 0, go to, but not including stepping by 2. Right? I got to give it all that information here. Now I can print. So games at the index will be the name of the game here. So this will be name, colon, let me do a formatted string here. The games at the index. And then maybe we also want to have then players is, that'll be games at the index plus 1. Right? Whatever that index was, one more than that will be the next line, right, in that list here, essentially. So we can get a prettier looking output here. Notice we still get these weird new lines here. Names, Monopoly. So if we don't want the new line character, we've got a couple options. I think strip is the one I like here. So strip will take out the white spacing here. So returns a copy of the string with leading and trailing white space removed. So if there's like spaces or tabs, or I believe it's new line characters as well. No, it didn't get rid of new lines? Oh, it did. Okay, no, here's my output here. That got rid of the new lines here for me. And then I can do the same with this one here. So we'll strip this one. We did this way back in strings, right? Remember we had strings back in like chapter something or other, 7? I forget which one it was. So strip's one of the options here to remove some of that, which is fun. So we could even do that with games up above if you don't want to change the ending character. You got lots of options here. So now we get the number of players, but again, it's still a string here. It's not numerical information yet. So maybe that's not super helpful here, but there's a list here, and maybe we'll ask them now. So how many players are playing, right? So we'll say players will be an int of an input. How many players are playing tonight? Oops, need another parenthesis. There we go. Now I want to go through and get just the games that match that number of players. Right? So again, I'm going to do similar idea here. I want to be ranging through as we go. Now, I only want the ones where the player range then is going to match. So I need to take this string and I'm going to split it. Remember, we can split strings into different tokens. So if I split on a dash here, I'm probably just going to get the low number and the high number, right? So I'm going to get that information here. So this will be my my low or player minimum will be my games at the index stripped here, right? Because we want to make sure we don't have those ending characters. So stripped. Then I'm going to split on the dash character, and the minimum should be the first one here, right? Index 0. So we're taking the games at index plus 1 to get that line. We're going to strip out the white space, and then we're going to split it on the dash. Then I'm going to take the first piece of it here. So we'll have player minimum, and then we'll have player maximum here. Maximum. And then if my player minimum is that one here, is less than or equal to the players, is less than or equal to the player maximum, then I'll print this possible game here, this one here. We'll do that one here. Didn't I get the print? I missed the print here. That's fine. Print. Ending the quote here. Players is an int. Why does this not like this one here? Player minimum less than or equal to players. Oh, it expected a string, right? I still have a string here, right? This is still a string. I haven't converted it back to an integer yet, so it's warning me, hey, this is a string. You're comparing it to an integer. That's not going to go very well for me here. So, right, take this as an int, and take this one as an int as we go. All right, now I've done all my arithmetic, right? And now I can actually, or now I've converted, now I can do arithmetic with it here and check. So how many players are playing? Let's see. So if you had 5 players, we're going to lose sorry, right? Let's do 5. Uh-oh. Didn't go through and give me more. What did we do wrong here? That should have worked, right? I think that should have worked. Let's try it. That's fine. So read. We want to continue. 5 players. Come on. Didn't I do 5? Oh, okay. Now I hit my breakpoint. That's what I was waiting for. So we have. No? Did I give it 5? Okay, that was weird. I thought I typed in 5, but maybe not. All right. So now we have players is 5. We're going through our index here, so we'll check player minimum is 2, player maximum is also 2. I copy-pasted wrong. I have the minimum on all of them, right? You guys didn't tell me I was doing a dumb thing. You remember, you got to tell me if I do dumb things here. So you got to grab the second number out of that split. That would be useful here. This is why debug is your friend, right? You can hopefully find out what's not working like we expect it to work here. So we got 5 players. We get all of our games except for sorry, because we filtered that out. Now, if we wanted 7 players, we get only Monopoly. Right? None of the other games play 7 and 8 players. Right? So we can kind of do something more interesting with the information that's in our file here as we go. And then maybe now we want to be able to ask them, hey, do you want to add some games to your library? Right? We could do that sort of thing. So if we want to go and write to our file here, we'll ask them, hey, do you want to add games? So games to add equals an input of do you want to add games to your library? And again, tell them, hey, I want a Y or an N here. This is pretty helpful here. And then, I don't know, while games to add equals a Y, and maybe lowercase this input just in case they're yelling at us and typing in caps here. I don't know, right? We want to keep those good habits, right? We don't want to be too lazy. So if we have a game to add, great, we'll go ask them, okay, what's the name of the game? So this is the name. Game name is an input. Enter the name of the game. Sorry, my sugar's high right now. What's going on? Come on. Apparently just drinking black coffee causes my sugar to go up. Which is a little confusing, but sure. Bodies are weird like that. I think it's the caffeine or something. All right, so name of the game, great. And then we need the number of players. So what's the minimum number of players? So minimum number of players. Did I spell that wrong? Minimum? Is that? Okay, whatever. Is an input of, enter the minimum number of players. And then again, we'll do the same for max. Maximum. Maximum. Oh, that's an X there. Is that like that now? Okay, good. Maximum number of players. So I've got some information. Now I need to write it to the file. So to write to a file, we can use open. Look at this, we open. But now we tell it, hey, when I open this file, I want to W this file. I want to write the file. Right? Which when you're teaching a kid how to read and there's a W and it makes an R sound, or it's a silent W, it's really annoying because we're teaching the 6-year-old to read. But we're going to write the file. So again, we just go open. So we call open. So I'm going to say, okay, well, I've got it here. So this is my games file equals open games.txt with W mode. This is write mode. So I've opened it for writing. Okay. Then what I want to do is I want to write the file. So I can then say my something whatever dot write. When you write here, you have to be specific. So you can read the file. This is the default flag, so you don't have to tell it read. It assumes you want to read unless you tell it otherwise. You can write the file. You can also open it for appending. This one is super handy here because when you write a file, it overwrites it. And then all your contents get blown away, which is pretty sad if you wanted to keep that there. So if you want to append here, right, add to the end of the file, we need A mode. So let's go to A for append, and then I think I need to make sure I've got one extra new line here. I should always have a new line at the end. So we're going to open it in append mode so we don't lose our contents. Right, this one's pretty handy here. Then I can go through and actually write that information out here. So I'm going to go just call write. I'm going to say, hey, I want to write this thing, write this thing, write this thing, whatever I want here. Flushing, don't worry too much about. This is more of an advanced thing. Because it's actually extremely slow to work with files in comparison to how fast the computer can work. Files are magnitudes slower than just regular operations in memory. It will do this thing called buffering, where it doesn't write immediately. It sort of has a little delay or waits till the buffer is full to actually go and flush out the buffer and write that to the file. You can do all sorts of interesting things to control that. We don't care at this point. It's not all that interesting right now, but you can. So we're just going to go and write. Okay. So we'll say, I want my games file dot write, and I want to write the game name, right? And then I want to take my games file and I want to write. Now this one I'm going to do a formatted string here because I want the minimum number of players, and I want a dash, and I want the maximum number of players. Here as we go. And I'll ask, do they have more games to add? Do you want to add more games to your library? Sure. Yes or no? Eventually we'll finish here, right? So let's give that a try. All right, so I don't know, 5 people are playing tonight. Do you want to add games to your library? Yes, let's add a game. So what game should we add? Anybody play? Chess? Oh, that's a great one, chess. Minimum number of players.
2.
Maximum number of players.
2.
Also 2. Okay, do you have more games to add? No. Let's take a look at our file. Uh-oh. We didn't add in a new line. So writing doesn't give you new lines by default. I'm going to go fix that for us here. Actually, let's just delete that. So we go delete that, and Control S for save, or to go file save to make sure we update that. So when we go write here, then let's do a formatted string. Let's take the game name, and then a \n. Remember \n's were our new line characters here? Those are handy. So we'll go add our own \n's. A single quote, there we go. So if we add our own \n's, let's try that again. So we'll run it here, 5 players, we'll do chess. Oh, yes, we have a game to add. We'll do chess 2 and 2, no more games. And now our games file looks correct. Looks pretty good here. So I think when this runs, right, this all worked out for us here. Yep. Cool. So now if we want to go play, 2 people are playing tonight, now we should get chess in our list here. That worked successfully here. Yeah, no more games to your library. No, we don't want to add any more games, and we close. So life is pretty good. So we're able to read and write this file as we go. The file system, because each operating system does things a little bit differently, there's a module you import here, which is the OS module. And remember, Python works on Mac, it works on Linux, it works on Windows, it works on calculators, depending on how smart your calculator is here. That's the NumWorks calculator. Didn't I tell you guys about that one? And it's like cheaper than the TI calculators, which have been expensive since even before I was a kid. They've been expensive, and they have a monopoly on the market, so they don't lower the price of their calculators, because why would they want to not make a lot of money when you're the only calculator brand? Anyway, so you can use the operating system module here to get a bunch of different things. This is a little bit complex. We're not going to worry too much about it here. We'll play with this in lab. To have said we've played with it here, and then it should work on any of your operating systems here. But turns out in Windows land, we use backslashes for our path. So if you look at the path here, it's directory, backslash folder, backslash folder, backslash folder, backslash folder, backslash whatever, backslash something. So we use backslashes. When you put a backslash in a string in Python, it says, oh, you want the escape character. We don't actually want the escape character. So if you want to give something a full path here, it's a little bit annoying as we go. We have to give it 2 backslashes. Or we can use the path separator here. So you can join things together. So if you do os.path.join, it will put in the correct separator for you, regardless of what operating system this runs on, which is really nice. So that way your program isn't going to be dependent on backslashes or forward slashes or confuse things, because Linux and Mac use the forward slash here, which is nice. So they'd say something forward slash. Now, we only really need this if we're giving full paths, which are almost never a good idea, because your program is never portable. If you say, hey, it's in, my file is in C, users, Eric, C, documents, GitHub, CIS, no one else's computer will have this folder, right? That's a terrible idea to put a absolute full path in there here. So generally everything we want to do is going to be relative. So when it looks at the path, it says, hey, where is Python running? And then that's the base folder. So anything relative to that, you can go up, you can go down, and usually we just go down into folders, into further folders as we go. So I can make a folder for logs, I can make a folder for the year, I can make a folder for the month, I can make a folder for the day, and then put a log file in that folder. That's terribly obnoxious to have folders by day, but sure, why not? I would go by month and then name them by day, but I didn't write this, so that's not up to me. So we get forward slashes and backslashes. So I can make a subfolder then, right? So if I want to come back here to my, I'm going to make a new folder or new directory here. We'll call this, I don't know, how about games? And inside of games, we'll put our games.txt. Now, when I did refactor, it picked it up automatically. So maybe I should have skipped that here. There's a quick little, it changed it for me here, and it's adding in the forward slash. And thankfully, Python and Windows are not so stupid. You can still use forward slashes in Windows, and it works. So all of this is to deal with some legacy issues before when it wasn't as smart. But now the fine folks at Python are like, why don't we just everyone use forward slashes so we don't have to escape anything? And forward slashes work in Windows too. So we don't have to worry too much about any of this anymore, which is really nice. But it's still out there, it's still a bunch of content. So anything we want to put in a folder, right, is still relative to my path here. Let me just kill my program here. So you'll notice when it runs here, right, it was running this file here. So it's going to be relative to where I'm running, which gets to be a little bit weird if you want to run stuff by hand. You have to start in a particular folder. Don't worry too much about that. That's more of an advanced topic when we get into like scheduling Python jobs and running things automatically and scripting and automation. We don't have to worry about that. We'll assume someone's probably going to hit your run button and we'll make this work. So it saves us a little bit of worrying here as we go. But we can use that OS module. You can do cool stuff with it here. You can do other things to check. So one of the things you can do is get like a list of everything that's in a given folder, and then you might want to do stuff with it here. You might want to say, hey, is this one a file? It's a file. Because maybe it's just a directory. Because you don't have to have names here. So bat chopper could be the name of a folder or directory. It could be the name of a file. So we can check, hey, os.path.isFile. Is this thing a file or not here? So it's a file or it's not a file as we go. You can check the size of a given file, which is fun. You can do interesting things with it here, not too much here. But OS walk will give us everything here. So this looks terribly ugly here, but we're going to practice it in lab. So what you get with walk is you get the directory, you get the subdirectories, and then you get the files of that given path. So the directories, or the directory name, right, is here. This is the 2009 logs folder, right? So we got logs and the year. So the directory we're looking at is logs 2009. That's the name of the directory. Then the subdirectories are all the folders within that one here. And then any given files, there were no files within that folder. Then we looked at, here's the directory name. Here's the subdirectories in that given directory. And then here's the files in that given directory. So this is going to give you the top level, and then the next time it runs, right, because this is the for loop here, it'll be the lower level directory. So the first time it runs is the top level directory. The next time it runs is the first subdirectory, and then the subdirectory within that subdirectory, and then the next subdirectory, and then the subdirectory within that subdirectory. So it automatically will drill down as deep as we need to go, which is really nice because on people's computers, I don't know how many folders they might have. Right? You can put folders inside of folders inside of folders inside of folders. It's crazy organized as you want to get, right? So if we want to go through, let's go, I'm going to give it a full path here just for fun here. So let's go to, so we want, I need the name of, so OS path join. So I give it a path here for walking a path. Well, I'll just copy paste this. So we need to import OS too. We don't need to input the year. So my path then will be, I'm going to grab my GitHub directory, our directory here for fun. And I think if I put that as a raw string, it'll ignore this. This is one of the things we mostly skipped over, raw strings. It doesn't escape things. It's like just read it as is, so it can save me a little bit of time here. Now I should be able to go through and walk all these. Why does it not direct typos? Nice. But I think at the end of this then we should get 2 players. No, there we go. Oh man, there's a bunch of junk out here. Because this virtual environment has a bunch of folders. Inside of that has a bunch of things, a bunch of things. Wow, that's more junk than we needed. Oh, here's the Git folder. That one's fun, right? Here's .git. Inside of .git has a bunch of other, this is all the magic stuff we never touch, right? So maybe if the directory name starts with dot, we should ignore it here. We can do that, right? So we can say if my dir name index of 0 is equal to a dot here, we'll just continue. Just skip it. Or you could say if it's not a dot, then do these things, right? I mean, maybe I like that. So let's do it. If it's not a dot, instead of a continue, now I want to actually go and do these things, right? Either way, we'll skip it here. I generally don't like the continue keyword. It is kind of handy sometimes, but so now we've hopefully cleaned up some of that stuff here. No more games. So we're close. Oh, I'm still getting my virtual environment though. Shouldn't that have cleaned it up? Let's see. Oh, we still got the .git. If it doesn't equal a dot, okay. What went wrong here? Let's put it in the debug mode and see. No more. No. Okay. So we got to our directory name. The directory name is the full name here, so it's not going to start with the dot ever. That's a bummer, because the next time this one runs, right? This is the first directory. Step over, rinse that one out. Now the next directory is my .git folder. Oh, that's a little annoying here. Okay, so we need to be a little bit more clever. So if we split this back up here to get the last little bit here, it'll be the last item that gets split when I split on my backslashes. Then I can find one, right? So let's see. So I want to take my directory names, .split on a backslash. So to split on the backslash, I have to escape the backslash here. And then I want the last index here, so that's -1. Right? And then the first character of that. Right? So this is the last directory or subdirectory. First character. Right? I think that ought to work. The -1 index will be the last one here, and then the first character. Let's see if that works for us here. No. All right, well, maybe not. Didn't work for us still. Oh, it did skip the first one, but it's not skipping the next one here. All right, so if any of them maybe have a dot in it, we skip it. Okay, so if not any of them here, so we want if Do I have to go through and skip them all? That's going to be annoying. Yeah, because there's a bunch of subfolders. Yeah, I don't want to have to do all that. All right. So we have to go through and look to see if any of them match. Here, then we should continue. All right, so for subdirectory in dirname.split, split on the backslash character here, and then if my subdirectory index of 0 equals a dot. Then we get a, so continue is only going to break this loop here. That's obnoxious. So we want to, so maybe we'll put a flag in here. So has, is hidden folder, or has hidden folder. Has hidden folder equals false. And if we find one that starts with the dot here, then we'll say has hidden folder is true. And then at the end of all of that here then, right, once we've gone through every subdirectory to see if we found one that starts with the dot here, if not has hidden folder, ugh. Maybe we should set this as is visible? Is visible? I don't know, is visible? Is not hidden? All right, all that seems obnoxious here. I wanted to make it so that they do this if this is true, but it's probably okay. That's a lot of work. 2, no. Hey, all right, I think, what is up with this VNV folder? It doesn't have a dot in it. We cleaned up a lot of it. So we got rid of the Git folder at least. We're getting through some of them. So the .idea folder we skipped, right? We didn't see any of that. We still have containers, PyCache. So there's a lot when it gets to files and folders, right? And again, we just wanted to kind of skip out some of it here. Some of this is more interesting, some of it's not here. So maybe we could add in other things we'd want to skip, right? Have a list of things to skip. Or maybe we only care about Python files, right? Maybe we only want to print this out if it's something with a Python file. We could do that sort of thing. So we'll practice using walk. It's a lot of fun getting things here. But again, the full path here, full path, it's generally bad. No one else's computer will have this path, right? So again, not super helpful for that. Usually we like the relative paths. It's like based on where this file is running, let's go and look for it here. Makes it much more portable as we go. All right, so that's probably enough on files for now. Let's flip over to project 3. That sound good? I should have started with that one here, but that's okay. So we'll go project 3. We go data save and do a new project. Project 3. Let me go commit all that here before I forget. 501. Oh, I don't want all the project 3 files. Files part 1. All right, got all that out there. So we're writing a bunch of classes here, right, for project 3. So this was our shopping cart, right? So class for item, name, quantity, unit price, set and get methods for quantity, unit price, just to get method for name, add a get total price, which is quantity times unit price. So this one hopefully wasn't hard. It's just some practice, a little bit of tediousness of going through all these steps, doing these things here. Not a whole lot of gotchas on this one here, but just to practice getting us into writing classes and then also writing the unit tests. That's a really important piece because any code that's worth writing is worth testing. Because if you don't care if it works, why'd you write it? Right? That's a pretty good rule of thumb here. Like if it doesn't matter if it works, then you shouldn't even be writing it. Right? If it matters if it works, right, then you want to make sure it does what it's supposed to do. And writing a main program that like takes user input all the time is kind of annoying. Right? That's really tedious too. And if we're breaking up work and kind of separating out, if I just want to write the class here, I don't want to have to do a bunch of user input or I don't want to have to do a bunch of things. And remember, people are really bad at eyeballing things. Like, oh, I expect this to come back out here. And then I look at it, and I'm not going to notice if one of the characters is off here because I'm really bad at that sort of thing, especially if I'm doing it over and over and over and over again, and it's been an 8-hour day. Like, how long do you guys spend staring at your computer, like, working, like work, not doing fun stuff? Anyone 8 hours a day? No? So like 8-hour days get to be really long, right? I'll be honest. By the end of the day, you're like a little bit tired, you're fatigued, you've been doing this a lot. So you don't want to have to trust that you're seeing the right output here is one of those things here. So making the computer do that work for us is awesome. And then building out a good test library is great. We can go make changes to it, make sure that we didn't break expected behavior is fantastic. We get these sorts of things. Did you see the VS Code? I forget what was all in that video here, but Microsoft / VS Code. So VS Code is an open source tool that Microsoft writes and supports and maintains here. So this is their text editor essentially, but it has all sorts of cool plugins here. And you can do all sorts of code. You can write Python and VS Code. It's fantastic. It's not as nice as PyCharm, so I prefer PyCharm, and it's got a bunch of cool bells and whistles in PyCharm as well. But all sorts of cool things here. So this one has tests. So when someone makes a commit to this repository here, tests go and run. So all of those tests. So unit tests is just one level of testing. There's a whole suite of testing. You get into like software engineering. You can talk more about the process of testing and things. But the tools that we use, like GitHub, our source control tools, can be hooked into to also run tests. So one of the cool things GitHub offers is hosting services for doing automated testing, which is really cool. So we can say, hey, when something is committed to GitHub, when my code changes, automatically go run all these tests, which is really nice to know. So, hey, when this thing happened, some of my tests didn't work. 5 out of 7 tests passed. 2 tests didn't pass. So something bad might have happened here. So we can go and look at these tests here. Hey, this package, whatever, failed. I don't even know what that is. I don't know. And this was skipped. I don't know any of these. I don't work with this product at all. Doesn't mean anything to me. This one is, hey, they're still running. They're still waiting here. But what this means is I can make someone else's computer run these tests. So I'm not sitting there waiting for it. And I can move on to do other things here. Right? So when the tests are checked in here, all of these things ran, which is nice. Hey, so we're doing Windows unit tests, Linux unit tests, integration tests, compile tests. I don't even know what all these things are. Mac tests, SDL sources, SDL source analysis. Sure, something. It does neat stuff, right? So and you can configure this and work with all these sorts of things. So this is another level that we can add to our product and our tools to make sure that things are working well, which is really nice. So we want to make sure we don't break things, essentially. And you want your software to be working all the time, which is nice. So our class here. So we're going to write a class for item, right? And we're just going to have an init method, right? Item had a couple pieces of information for item. Now, if we don't have set methods, we need to make sure we take that in the init method because there's no way to set that value outside of init. So we have set for quantity and unit price, but not name. Right? So once you set the name of an item, it's always that item. Right? Once you put ramen noodles on the shelf, they're always ramen noodles. We can't change the name. You can change the price, you can change the quantity if you want, but we're not changing the name of it here. Okay? So we definitely need name. If we wanted, we could add quantity and unit price in as well, or maybe we could give them defaults here, but at least we need name. So maybe I'll do quantity, and I'll default that one to 1, or maybe I'll do unit price. I don't know, I'll default that to 1 because you probably don't want to default it to 0 because free is a bad thing here. If you're a store, you probably don't want to give things away for free. And then quantity, again, we'll probably default to 1. So self.name. And then, again, we want to make these things hidden here. And we're going to assume people won't go mess with them, right? But we want to make sure they don't show up on the list of available values here. Is the name, self.unitPrice. Price is the unit price. And self.quantity is the quantity. Okay, so we've got those, and then I need set and get methods for the other ones, and just a get method for name. Again, I'm feeling a little lazy here, and we're running a little short on time, so let's go ask the chatbot to do this really tedious thing for us here, given this class. And then we'll go copy paste that in. And it should give us some decent sets and gets pretty easily here. Some of our tools will actually give that for you here. This one I don't think does, which is a bummer here. No, I don't think this one. Oh, AI. Oh, that's the one that we have to pay for, right? For AI actions. Yeah. Oh, generate. Yeah, generate. So depending on your tool, some of this will do it for you here as we go. But here we go. Okay, so here's the init we gave it here. So here's the get, set. Oh wow, that's giving us a lot of fancy code here. And we're going to say, here was my prompt, right? So we're using umgpt umgpt. Here's the prompt we gave it. Right, and here's where we got, here's the get unit price, set unit price, raise a value. This is nice, right? This is probably a good idea. Right? If you give me a negative value, tell me it's bad. Like, it picked up on that just based on the names here, which was nice, right? That wasn't a requirement because we hadn't got to exceptions yet, right? But that's a nice thing to do. So sure, I like that. Quantity, if it's less than 0, right? You can't have a negative quantity. I think that makes sense. So that was pretty good. Right? All right, so we got all of those, right, generated for us. That was nice. If you didn't have the value errors, don't worry about it. Like, I didn't ask for those, so sure. If you wrote it by hand, that's great too. Then we need the get total price, which is returns the quantity times unit price. Now, you could also ask the chatbot for that, but that's defeating the purpose, right? We want to practice the things that we're supposed to be doing here to get better at it. Writing sets and gets is really boring. We don't need to do a lot of those, but we can write our own get total price, right? And again, you need to be writing at least half the program, right? You can't turn in the English paper with more than half quotes, right? You'll fail English really quickly that way, right? You'll also fail programming that way really quickly, okay? Right, that's what we've been working on. Apparently there was a student panel on student perspective to generative AI. I meant to go and it ended up getting busy, but that sounded really cool. So it's a cool tool. I love it. Saves me a lot of time, right? A lot of developers use some sort of AI tools, but we got to learn how to use it the right way. Right? And hopefully you've heard that from me repeatedly. If not, I apologize. I'll keep trying here. And again, other profs will have other views on that, and just smile and nod, right? You're probably not going to win an argument with them. It's probably a bad idea. I'll be honest. So just smile and nod, right? Okay, so we'll get total price. Right, so this one returns a string here of, oh no, I'm sorry, this returns the value, just quantity times unit price. So this one's pretty quick. So we're going to return self.quantity times self.unit price. Unit price, right? That one's not hard. That was pretty quick, right? Then we write the string. We're overriding the string function here. Returns a string value with all the details. So I'm just going to grab that for a second here as a note. So that's under string. So we're going to return, and I want something that looks like this, right? So it'll be a formatted string. And it's going to have the self.quantity, space, self.name, right? And then the @ sign, and then a $sign, and then self.unit price, and then dash, another $sign, and then self. Now you can call our own get total price here, right? You don't need to do the arithmetic again because we already have the one that gives me the total price, right? And if you wanted to format this nicely, great. We're probably not going to matter because we're just multiplying. We're probably not going to run out of decimal, like have this repeating decimal forever. So I'm not worried about it. If you added it into formatting, great. If you didn't, that's okay too. Okay, so we've got that. So I think item class is probably done here. Here's our class for item. Awesome, so now we're going to test it, right? Make sure it works and does what it's supposed to do. Now, testing gets happen automatically when we're testing if my values get set, right? Testing sets, like if we write the code, we probably want to test it. There's the idea of code coverage. You can get, if we only test that it's successful, then this bit of code never runs when I test it. I have no confidence that it actually works. So we're testing, we want to make sure every line of code we wrote gets ran. So ideally, if we write this, we'd have two different tests. So we'd have a test for setting it properly, and we'd have a test that says, hey, I got an exception back if I gave it a bad value. We're going to skip that because it would be a nice to have. I didn't ask for 100% code coverage. I just said make sure it does what it's supposed to do, and chatbot was extra fancy for us. Anyway, so we're going to say, I want to go to test. It says, I don't have test. You want to make new ones? Yes, let's make new ones, please. So test main, sure. Now, I don't want to test any of the gets. I can test the sets, sure. When they get set, that's going to happen automatically. So get total price is probably the best one here. And then the other thing you can do to sort of, you want to make sure your code runs and not have to test set separately. Instead of setting the unit price directly here, I can say set unit price, given that unit price, right? Which will also make sure I don't have to do that same is it not negative check twice, right? Use my own function here instead of being lazy about it and just taking the value. So then I can set quantity, given the quantity. Now when my init method runs, when I make an instance of item, my set method's already run. My set function's run. So that code got tested just by creating an item rather than me having to make a separate test for set. I'm kind of lazy. I don't like all sorts of different tests here. Again, it's probably nice to do at some point if we've got a bunch of different checking here. I want to make sure we get our value errors, but we're going to take the easy one here. So just testing get total price then will essentially run all of our code here. Okay, and we could even do get quantity, get name, and get unit price. There we go. So all of the gets are running as well with our string as we go here, which is fantastic. So we're going to arrange, we're going to act, and we're going to assert. So what do we need here then? So what we're expecting to have then, we'll have a name is, how do we do bananas, right? Bananas, we'll have this is my expected name, my expected price is, what do we say, like 30 cents each, and expected quantity, what do we say, 7 bananas, there we go, quantity, and then an expected string is going to be, that's 7 bananas at whatever here. Is that still in my clipboard? Probably not. Hey, it is. Awesome. Thought it might still be. So I should get back the string out here. Now, I'm not actually going to use these ones. So maybe we just call them name, price, and quantity. It doesn't matter too much here. And then we make an item. So here's my item equals item. Now I have to go import here. So from main import item. So I'm going to make an item. And I'm going to give it the expected name, the expected price, the expected quantity here. Okay. Now I'm not testing the init method, so it's not in my act section. The act section is what we're testing, the code we're testing here, right? So then this will be my actual string, is a string of item. Right? I'll get the thing back out here. Right? If we're testing our sets, we do our sets here. If we're testing something else like drive, or we're testing add fuel, or right, those sorts of things, we can put them in act here. And then we're going to assert, did I get back what I expected? So self.assert equals, assert equal, my expected string and my actual string. Did they match? And I can go and run my tests. Uh-oh, it failed. 7 bananas at, oh, okay, so because I didn't add in the extra cents here, so I didn't do the padding with it here. Sure, I'm just going to take them out here because I don't care. If you went through the trouble and made sure it was padded to 2 and it showed your pennies, fantastic. I'm a little short on time and feeling lazy here. All right, we're getting close. Let's see, what didn't work here now? So this one does not equal this one. Oh, I forgot the slash each here. Okay, so slash each. There we go. He wasn't paying enough attention here. At the unit price slash each. There we go. We'll fix that in our main function here. Let's go and test it again. All right, we're getting closer. 7 bananas at, oh, I don't have the 0 here as well. Oh, I do have the 0. So 0, 3 each. Sure, again, if you wanted to fix the formatting, great. I'm not too particular right now. And now we get it to pass. Right? So now it finally matches. So this output string matches. So I unit tested, and all of the code in my item class ran except for these raise value errors. Right? My quantity set and gets ran, right? Because they ran when I used my string function. Ever so slightly cheating, I'm not so worried about it here because we're just exercising our code. Sets and gets are not all that interesting. That make sense? So really just the one unit test, if you wanted, was sufficient for that one, for item. Right? Then we're going to write our next class. Right? We're going to class for shopping cart. So shopping cart then has an attribute for the list of items. We're going to have a function add item that accepts an item to add to the list, and a function for receipt, which returns a string of each item, details total price, and then the grand total. Okay, sure. So define init method. Doesn't take any arguments. It just starts empty. When you grab a shopping cart, there should be nothing in it. Otherwise, you'll probably be upset at Meyer. Right? Stop putting things in my cart for me. Right? So self dot, this is my items then. Again, making it private, we don't want to give public access to this thing here. It's fine. We'll say it's a new list. And then we have a function for add item, given self in item. And I'm going to say, hey, this should be an item here. Again, this is totally optional, but will make my IntelliSense work a little bit better, hopefully here. So we'll say self.items dot append the item. Okay, and then a function for receipt. Receipt, IEPT. Terrible at spelling here.
CPI.
C-E-I-P-T. Thank you. All right, so we need a receipt to return here. So we're going to start with, I don't know, value or something. I don't know. Sure. It starts as an empty string. And then for item in self.items, we need to take my value, and we're going to add to it the item as a string here. I mean, it'll probably do that automatically, I think, when you try the plus equals. Right? Turn it into a string, and then we need new lines as well, right? Plus a new line character. Right? Or you could do a formatted string, whatever you liked here. That might be easier. We'll do a formatted string. The way I get item automatically. Remember, formatted strings will try and convert stuff to strings for you. And a new line. And then we also need a total. Starts off at 0, and we'll take my total plus equals the item.getTotalPrice. Right? So if I told it it's an item, the getTotalPrice was showing up for me here. Right? If I didn't tell it it's an item, it probably didn't know it was an item. So item dot. Oh, okay, this still has it here. But usually that helps it understand, hey, this should be a bunch of items here as we go. It's just the magic is really cool. We get the total price. When it's all done, we've added every item then we'll add my value. We'll add in here the, what do we want to say, grand total, plus equals a formatted string, grand total, and that's just my total. Probably a dollar sign in here, right? Make it look a little bit pretty. And then we're going to return value. Maybe come up with a better name for value here, but that should be okay. That's my shopping cart. So we want to test, does it work, right? So let's go to shopping cart, say go to test. Don't see any tests, let's make some new tests and put them in test main. I want to test receipt. I'm going to add items to get my receipt back out, so I don't need to test that separately here. Okay, again, we're going to arrange. We're going to act. We're going to assert. So we need a couple items then to test here, right? So we'll make a shopping cart. So we need to go and import from main. Oh, we can just add a comma here. Right. Importing item and shopping cart. There we go. So I'll say, here's my cart, here's a shopping cart. Okay, and I go add a bunch of things to it here. So cart.addItem, and I want to add an item, and I'm going to say this is bananas at 0.3 cents at, I don't know, 7 of them here. And then we got to add a couple of things to it here. What else do you want to add to our cart here? Let's add like 3 items. 2 is probably enough, but okay, let's just do 2. We're running short on time. What's the next item we should add? Apples, okay. How many, or how much do apples cost each? They're like 75 cents each, maybe? And how many apples are we buying? 5 apples. All right, cool. And then we're going to have an expected receipt. Now, this will be a little bit messy here, so I'm going to do the triple quote here. It'll be a little bit easier for me to type all this in because it'll be the literal what's here. It looks really weird, but it'll be okay. So we're going to have a bananas at whatever here. Don't need extra quotes here. And then we'll have 5 apples at $0.075 each. $5 for 75 cents. 4 is $3, so $3.75. $3.75. And then a grand total. What do we make that say? Grand total colon $. That's $5.85. That look right? Okay. Grand total, $5.85. Awesome. And then I end my triple quote here. This just lets me write it without having to do my own appends, right? All right, then we'll act. So we'll make our actual receipt. Here's my cart.receipt here, and then we'll assert, did they match? Right? So self.assert equals my expected and my actual. Give that a run. Test receipt. Okay, it failed. That's okay. We're getting close here. So this did not match this. What doesn't match here? 7 bananas at 3 cents each. That one looks good. 5 apples at 75 each. Looks okay. 5.85. Okay, I think there might be an extra new line maybe? I don't know. Let's see. So let's put a breakpoint in here, and you can debug your tests too. I'm not sure exactly what went wrong here. My expected receipt. Okay, and let's step over. I want to get my actual receipt and look at the 2 here. Oh, I have a new line character at the beginning of my, okay, yep, so the triple quote screwed it up here, is it gave me a new line to start. So I have to start the string on the same line here as I go. All right, let's see if that works now. Hey, all right, my receipt passed. The triple quotes are a little bit weird, but that way I don't have to do a bunch of appending, and I can just keep on stringing my one line together here. Okay, so here's my test for receipt. Again, I added item, I was testing it, it's there. I don't really need to go through and do a bunch of extra work to test that separately. It might be a good idea to do, but I'm doing it all in one here as well. It's ever so slightly bad to test more than one function at a time in a unit test, but again, for our purposes, we're not too worried about it here. So our unit tests, and the last bit was actually writing a program that works. Right, so now the rest of our code here. Now this is a little bit ugly to be like in here and have its own code. So I'm going to rename this one here. Let's go to refactor, rename. Let's change this one to what do I want here? Like classes? I don't know. .py? Sure. I'll just call it classes. And I'll go add a new file here for main. So we want a main.py file here. And then say from classes, import item and shopping cart. Classes, import item and shopping cart. Oh. All right. So we need a cart. So cart equals shopping cart. Great. And then add items to, and then print the receipt, looping until they're done. So do you want to add an item? Do you want to print the receipt, or be done here? So while their option equals something, and while option does not equal done, we'll get an input. Ask them what they want to do, or maybe we can say if option equals add item. And we'll do something else if my option is equal to receipt. I guess that's it, right? You're going to add a receipt, or you'll be done here. And at the end of all of that, then we'll say my option is equal to an input of to add an item, print the receipt, or be done. I don't know, that's a terrible looking menu, but that's okay. We'll figure it out. Okay, so if we're going to add an item, then we need the information here. So we need the item name. Item name is an input of enter the item name, the item quantity or unit price. I don't know, price sure is a float, right, of an input. The unit price and item quantity is a float again of an input of enter the quantity. And then we'll make an item. So item is an item, given the name. Oops, item name. I guess we could have just called these name. Let's just save a little bit of typing here. We'll go name, unit price, and quantity. Great, and then we'll take our cart.add item, given the item. Okay, if we print the receipt, we'll print cart.receipt. That's all we gotta do, right? It returns a string, it doesn't print it itself, it's just returning that value, and then it can be done. So this one ought to run, if we run this one here, run main. We want to add an item. Let's add bananas at 30 cents each. We want to buy 7 of them here. Let's do the receipt. Here's my bananas with the grand total. Let's add an item. Let's add apples. What do we say? 75 cents each. We bought 5 of them. We'll print our receipt. Here's $5.85, and we can be all done. Cool. So we got a main function. Actually, not too bad, right? For 5 points, that's pretty quick here. Like that's less than some of the other projects were, but again, we're just kind of practicing using these things here, right? So we could essentially do this and say, okay, here's my unit test, but testing it by hand again is bad, and we're going to miss those sorts of small little details here, like, oh, hey, maybe I didn't have the extra 0 here that I noticed when I was doing my other printing here, because I'm just not going to pay that much attention, right? Are we okay so far? Make sense for project 3? All right, awesome. So let's do project 3. And push. All right, and then the final project here. Let me go get you a new link here as we go. Now, the final project, I'm going to be particular here on that we need to have 10 commits over the next month. So we've got 30 days. So on at least 10 separate days, you're going to have to make a git commit with some amount of work, right? More than just like change a line, right? It doesn't need to be 100 lines of code have changed, but some happy middle, like you've done some incremental amount of work to the project. Right? The idea is, as we write our software, we're going to be able to run it. right? You don't need to have all the features. We'll take, here's a small little bit. I want to be able to run it to make sure it does this small little bit at a time. I want to add new features, get it running, add new features, get it running, add new features, get it running. Does that part make sense? So I'm not going to actually run all 10 of your commits. That'd be a terrible lot of work to have to go through. But the idea is you're working at it incrementally. And then that also then ensures you don't just go get a solution, copy paste it in, right? Or get a solution and copy paste in 1/10 of it every time. It's really obvious when people do stuff like that, I promise, right? Because I don't even write code that works the first time, most of the time here. So if I never see that, like, code being changed once it was added, I know you didn't actually do it. I'm just gonna be open here, right? Like, nobody does perfect, here's 10 commits, here's only adding code, only adding code, only adding code, only adding code. That never happens, okay? Don't work hard to make it look like you cheated or you didn't cheat. Like, just do the work, please, right? The goal of this class is that you get better at programming. Because if you don't learn how to program by the end of this class, the next programming class you take, you will fail. Or the one after that, you will fail. At some point, you'll be failing classes because you don't actually know how to code, right? You know, the computers can do a lot of it for us, but not all of it, right? So we want to be practicing it. So hopefully you're here because you actually want to learn something, and then hopefully you want to get a job and make some money, because that's what our society does, right? We need to be productive members of society for reasons, and money is good to have and spend things and pay off your student loans and those sorts of things. It's not a bad cycle, I promise, or a pyramid scheme at all. So that sort of thing. So please just do it, okay? But I guess that's my long-winded story of that. So final project. Go grab my repository, template. Oops, did I spell my name wrong? Python template. Yeah, there we go, come on. I just had a load, okay. All right. Oh, I found that Monopoly video, did I tell you? I posted it in my Discord. The stand-up maths, I don't think it was stand-up maths. Maybe it was stand-up maths who did a Monopoly video. It was really interesting. So he simulated it. So let's go to new project. Did I add in final project already? I did, okay, good. So let's edit this one here. So please submit the URL and a self-assessment using the rubric. I'll give you the rubric in a little bit here, and then if you pardon me, I'm just going to go copy paste here again, because I thought this was a fun project last time. Final project. We're also going to do Monopoly, because Monopoly is fun. Okay. So a couple things, though. Ours is going to be a little bit pared down, because Monopoly itself is really complex. Okay, so we don't need to do all of the things here. We're going to do a simpler version. Right? So if you want to work with a partner, if you send me your GitHub usernames, I can give your partner shared access to your repository, so you can both make commits to it. There's a couple extra steps. You want to make sure you're not working on the same file at the same time, or like you're pulling before you push. Things can get out of sync. I can help you get stuck if you're different here. The Git requirement here, you have to have 10 commits over 10 different days. Right? If you don't have this, you don't even get any points at all. This is not optional. This is mandatory. Have to have at least 10 commits. We got a month, so I don't feel too bad doing this. And a lot of people have said, not everybody, they're like, thank you, because that made sure I started early. You don't have to thank me, I promise, it's okay. But like, it makes you start early, because you have to have done some work over a period of 10 days, right? We're not just doing this in one all-nighter. That's a terrible idea, right? I get it, I've done it before, I'm guilty, but we can't do that with this, okay? All right, and our very basic version of Monopoly. There's no chance, there's no community chest cards, so we don't need to worry about any of that nonsense here. When our program starts, we're gonna ask them if they want to start a new game or load a game. We'll figure out the save and load later, right? Get that part working later, because we want to be able to save files, write files. But for now, just, as we're doing it incrementally, don't start with that. Right? Start with, let's just get a basic game working here. So with a new game, it's 2 to 8 players. And the players take turns going around the board spending money. If they land on the property that isn't owned, you can buy it if you have enough money. If someone owns it other than the current player, they have to pay rent to the owner. This is Monopoly. If you haven't played before, I apologize. Maybe I'll bring in a game we can play in lab sometime. If you run out of money, you're out of the game. When a player loses, set the property back to unowned or give it to the player they lost to. This is your choice. Usually you give it to the player you lost to, or you could sell it. You could do all sorts of complicated things in real Monopoly. Just pick something easy. Whatever you want to do, I'm okay with it. Pick an option. And we're going to have at least 2 classes here when we work with our code, right? So it's not just going to be one giant dictionary. Right? We have to use classes because we understand object-oriented programming. I promise this will make saving and loading easier. I'll show you on Wednesday, okay? So player will have name or number. Hey, this is player 1, player 2, player 3. This is player Eric, player Jeb, whatever here. Their cache, and then the current space that they're on. And the property has its name, has its purchase amount, has its rent amount, and the owner name or number. Again, whichever option you went with. Hey, it's owned by player 1, player 2, player... Or you probably want to start at 0, right? Player 0 is going to be at index 0. Because that will make life easier for us, that sort of thing. For jail, have the go to jail space, but don't bother with the rules of rolling doubles 3x in a row. Just skip the doubles rule if you want. If you want to add it in, cool, because you were having fun with it, go for it. If you just want to skip it, that's fine. You just pay $50 and you get out immediately. So the go to jail space you land on, you pay $50, but you've moved across the board back here now. And you didn't pass go, you didn't collect $200, right? But just charge them $50. That sort of thing. So a somewhat simple version here. So the places where there were chance or community chest cards, they're just open spaces now. Nothing happens, right? If you want to add in something, go for it. You can feel free to do anything interesting that you want with it as you go, but this is the minimum that we're getting here, okay? So little bits at a time. Hey, let's just make a board that can go around. That's a nice, easy step. Okay, now let's start putting some names on some properties. Okay, maybe now we start doing some rent on them. Like we can start building out little bits at a time as we go. It doesn't have to happen all at once. That's sort of the idea here. Then once we've got the information, we got a game running, we can figure out saving and loading, right? Again, we'll spend more time on that on Wednesday. It'll make a little bit more sense, but hopefully we can get going on it as we go here. So I'm not going to mark it as a group project because that gets to be a little bit annoying. So if you do work with a group, just let me know, but you'll both submit individually. It'll be fine as we go, okay? All right. Oh, sorry, we went a little bit over, but I'll see you for lab at 2 o'clock. Make sure you get your coffee, and we'll have some fun with files.
Yeah.